Hello, everyone. Welcome to week number 3 in Science 200. You have gotten started on your topic, and now this week we are going to look for scientific sources that help support your viewpoint or help give you information about your particular topic. So that's what we will concentrate on this week. All right, last week you learned all about John Snow. He was a medical doctor in London, England, and he showed that cholera, the horrible dysentery disease that can be life-threatening and deadly, is actually caused not by miasma, which is the funky smelling odors in the air. It is caused by contaminated water. And drinking contaminated water from sewage that contains the bacteria that cause cholera, Vibrio cholerae. So he showed this connection, and how did he do it? He did it in a very scientific way. He mapped out every case of cholera in different neighborhoods, including the deaths, and he showed their locations on a map. And then he showed where those particular locations and communities in London were getting their water. And he showed without a doubt that the cholera cases came from contaminated water from the Thames River. So that was a very interesting study. I hope that you enjoyed it because it gives you a little bit of history and shows you how public health works. We have seen examples of that in our day with COVID. But you did get to see how it worked way back when in the 1800s, 1840s, and 50s, and how opinions were different back then about what caused disease and what causes disease than what we understand today. Okay, this week you're going to learn about using scientific sources. So you are going to have to look at scientific literature. Okay, this is totally different from news articles or opinion pieces or just doing a Google search. That is not how you do science. So you're going to look for scientific sources. Where are you going to look? The Shapiro Library should be your starting point. And we have some excellent sources, and you get the full articles, which is awesome. In the Shapiro Library, there are a couple of others that you can, a couple of other databases that you can look at. PubMed is one, PubMed. You probably are only going to see the abstracts there. You can also use Google Scholar. This is not a Google search. Google Scholar shows you scientific papers. And sometimes it's more specific even than PubMed, which is what I've depended on for decades now. But Google Scholar is really good too. But start with the Shapiro Library to find your scientific sources on your particular topic, whether it's ocean acidification, electric vehicles, biodiversity conservation in a particular area, whatever it is. Okay. Then you're going to have these scientific sources and you have to read them. And when you first look at them, they will terrify you because they are full of information. There's lots and lots of words, very few pictures. There'll be some graphs, hopefully, but no pictures. And it all looks complicated. So here's a way to start. The way to start looking at a scientific paper is to read the abstract. The abstract should be a paragraph long. It's at the very beginning of the paper, and it basically summarizes what this paper is all about. It tells you what the question is that the scientists are trying to answer, background information about why this is important. It tells you how they did their experiments. It tells you the very basics of their results. It tells you what their conclusions are about those particular results, what they mean, and also what are further questions that need to be asked about this topic. So that's the abstract. Always start with the abstract. Don't start trying to read through the whole thing. Yeah. No. So if this is a good article for you, which let me skip down for just a second. you need to find credible and relevant sources. So the first thing that I would say is when you read this abstract, does this have anything to do with my topic? And you'd be surprised at how many times you say, no. So that's relevancy. Okay? Is this relevant to the question that you are asking? Is it relevant? If it's not relevant, even if it's a wonderful study, how does that help you at all? The other thing that you have to look for is it a credible source? So you have to look at the authors, look at the end, see where these people are from, see if they have any financial affiliations with any part of this study, and sometimes they are being paid by individuals or companies to do work. So make sure you read that and figure out where these people are from and whether they are credible, because sometimes you will find out that they give particular opinions because they are paid to give particular opinions. You know all about that, right? So anyway, you're looking for credible and relevant sources. So now that you looked at that abstract, can you use the information in the rest of the journal article? Absolutely you can. All right, so you've got the introduction. The introduction is going to tell you the question that they are going to ask and going to try to answer in this particular study, and all the background information that tells you the significance of this, why they're asking it, why it's important, what we already know about it. Then you get into the methods section. You probably aren't going to use that section because you won't know those techniques that they're talking about, and maybe they're not all that important for you to know the minute details of the methods. Then you go to the results section. Now usually you need to look at this. Here's where you'll find the graphs, data tables, sometimes some photographs, that sort of thing. Look at the results. Look at the captions. The caption is the big title at the bottom. Usually that's where it is. At the bottom, read through that whole title or caption to see what this graph is actually showing you. And then look at the axes. What are they measuring on either axis, the y-axis or the x-axis, both. So take a look at the results. Then look at the conclusions. This is a very important section. It tells you what those results mean, and it tells you why this is important and what are the further questions that need to be answered about this particular topic. So those are the parts of a scientific paper. If you get stumped and say you only find one really good article, here's another clue for you. You can look at the end of that article and look at their references, because they'll have them all spelled out, and see if any of their references would help you with your paper. So you can look at it from that viewpoint if you're not being real successful with any of these other databases. Okay, so I talked about credibility and relevancy. You need to find 3 good sources on your topic. And I don't mean just general, really general sources. One other thing that you can look for, I think we learn about this in the next chapter. If you're not having any luck, say you're looking up ocean acidification, and there are just so many articles out there, and you're not sure which one to look at, do this. Add this one word, review. So there will be a scientist who has looked through the scientific literature and compiled a whole bunch of articles and made sense out of them all. And that's what a review is. So reviews are extremely helpful when you're trying to find general information about a topic, because that particular scientist is going to write this in a way that you most likely can understand it. And it will be all kinds of research about your topic. So do add that term review to your search term if you want to look for an article like this. Okay, so you're going to find 3 good sources on your topic, and then you're going to evaluate those sources. and you're going to do that in the textbook. There are a number of different assignments this week in the textbook, and 3 of them will be on your 3 different sources. Plagiarism issues, this is also covered in this chapter. So plagiarism is the use of someone else's work claiming to be your own. You can do this unintentionally. So you can hear something and then you can repeat it. Okay, if you do that, that's all right, but you should give credit to the person or the authors who proposed this particular idea, who proved these facts, whatever it is. There's also intentional plagiarism, and this is becoming more and more of an issue anymore. You can buy papers, and I know that you can, and you know that you can, out there on the internet. Unfortunately, they're usually not really good. And the one other problem that you have in this course and at SNHU in general is that you have to turn in your papers through Turnitin. Turnitin is a huge database. It's a database of every paper that has been turned in at SNHU, plus all the other papers that have been turned in everywhere. And it does a search, and it looks to see if your information is the same as something else that's out there. And you have the ability to look at that and to look at your similarity score. If you see a high similarity score, that means that your work came from somewhere else. So be really careful about that. You need to cite your sources. You need to give them credit in the body of the text for this particular information, and you need to include their reference information. So be really careful about plagiarism from this point out in our course. You have discussion board posts this week. So you have an initial post. Initial posts are always due by Thursday night. All right, here are your questions. What was the biggest challenge for you in analyzing a scientific source? And if you don't say the scientific jargon or language used, you're missing out, because that is true for me. If it's not my area, then I'm not going to know all the terminology. I know it for what I do and what my specialty is, but I am not going to know it for other specialties. If you ask me to read a paper about a fungus, no, I'm going to be looking up a lot of terms. So jargon is number 1. So tell us about your challenges in analyzing a scientific source. Maybe for you, it's actually finding one, which can be an issue. How did you overcome this? How did you get to the point where you could actually understand the source? Use examples. Use at least 2 examples. Say, I looked up ocean acidification and I found this one source and it was so difficult to read, I couldn't understand a word of it. Okay? So use some examples, 2 examples at least, in your initial post. And then you have 2 response posts, 2 responses to your classmates. Make sure you use their name too. Really, isn't that polite? Hey, Blake. Hey, Jalen. Hey, Anya. Hey, I don't know. Names are slipping out of my head here. Name the person that you're talking to because you're talking to a classmate. And you have 2 response posts that are due by Sunday evening before midnight. Compare your challenges to theirs. Did you have the same challenges? Did you have something different? Similarities, differences, and share your tips, any tips that you have for analyzing this type of source. We can all learn from that. I learn from what you say because I know how to do this and I've been doing it a long time. And so it helps me to read what you say so that I can help other students along the way. And then finally, our tip of the week is use what you learned in the textbook to answer the discussion board questions. This is very helpful every single week. Oh, there's my sea eagle again. Remember, I took this picture off the side of a boat that was moving. Yeah, anyway, I'm very proud of these pictures. Use what you learned in the textbook to answer your discussion board questions. that will help you. And follow directions for completing your assignments. Your directions are called guidelines. Okay, so whenever you see that word guideline, that's what it means. Those are the instructions for doing an assignment. And remember that the rubric is how this will be graded. What's a good grade on this? What's an okay grade? What's a not good grade? That sort of thing. That's a rubric for you. And that's what I use in Brightspace to do the grading for your work. All right, with that being said, I hope that you have a wonderful week this week. I'll be headed out to the sunflower fields again. That first slide showed you a picture of a sunflower that I took this week, and I'll be heading back out in 2 days to take more pictures. If you need anything, there's my name, Dr. Janie Sigmon, m.sigmon@snhu.edu. I'll also be doing my Sunday evening online office hours at Office 40 Minutes on WebEx starting at 6 o'clock Eastern Time, so maybe you'll join me there. But please let me know if you have any questions whatsoever. And with that, have a great week.